So now we begin integral calculus, starting with indefinite integral, and then we move on to definite integral. From point of view of GATE, indefinite integral questions they seldom ask, but the methods are applicable in finding definite integrals also. So we will be discussing the basics of indefinite integrals, and you don't have to go into much difficult and very typically difficult questions as you might have faced in IIT JEE type of exam, especially advanced type of exams. You just need to know the basic properties, but what I've seen with many of the students is they do not have a grip on integrals, either definite or indefinite. So whenever they bump into problems, even there in the core discipline courses, they bump into problems where they have to do an integration, they are lost. So immediately they are switched off. So indefinite integrals is a very important topic. Let us review that. So I have given you notes up to definite integrals, but sorry, up to differential calculus, but I'll be sharing the notes on indefinite integrals. So let us begin. Okay. Now let f be a differentiable function of x. Capital F be a differentiable function of x such that the derivative of the function capital F of x is small f of x. Then say small f of x is derivative of capital F of x. But then this function capital F of x is known as the primitive or the antiderivative or the indefinite integral of f of x with respect to x. So this is the indefinite integral. And why is it indefinite? Because of this integration constant c. This constant c can take any real value. So this function here that is being integrated, that means the derivative which is being integrated, is called as the integrand. This is called as the integrand, and this is called as the integral. So integrand is that which is being integrated, and this is the integral. Now, why is this called as an indefinite integral? The reason is simple. So suppose, very simple, we have function x cube. The derivative of x cube is 3x square. Okay. Now the derivative of x cube plus 3 is also 3x square plus 0. The derivative of x cube minus 5 is also 3x square. So now if you integrate 3x square, we'll get x cube for sure, but it can be any value, either 3x x cube plus 0 or x cube plus 3, x cube minus 5 or x cube plus 1, x cube, any constant. So you're not sure of which is the actual function. Therefore, this is the indefinite integral. If you want to know what is this constancy, some other properties of the function, you need to substitute and find out the value. For example, if you know that the function is equal to 1 at x equal to 0, so then you substitute x equal to 0, then the value of c will be 1. So this is the indefinite integral. So indefinite integral is antiderivative of meaning it's the inverse process of differentiation. If we know the derivative, then we can find the antiderivative. So I have given a list of functions. Now, there are methods of integration. One, it is based on standard results. Other, it is based on substitution. So one by one, we will go through. However, based on standard results, let us do this. The first method of finding the antiderivative is using the standard results. Now the standard results, we have to simplify the integrand into one or more known integrals. One or more known integrals. So this is the list of integrals. Very, very important. And it is a must that all students memorize this list. Okay, there is no scope not to memorize this list. If at all you want to skip, you can skip hyperbolic functions, acceptable. But all of the others, you will have to memorize it. Okay, you will have to write it on your own. So derivative of integral of x power n dx is x to the power n plus 1 upon n plus 1 plus c. Of course, n cannot take the value minus 1. If n takes the value minus 1, this is the integral. 1 by x. Derivative of 1 by x is log modulus of x. Why log modulus of x? Why not just log x? Because we don't know what the value of x is. X can be a negative value, but log cannot be defined for negative of x. Log can be defined only for positive of x. So even if x takes negative value, modulus of x takes care of it. Okay. So modulus of log of mod x will be the antiderivative. Then integral of e power x is e power x plus c. Integral of a power x dx is a power x upon log a plus c. The derivative of a power x is a power x log a. So integral will be reverse, meaning instead of multiplication with log a, it will be division by log a. Derivative of cos x is minus sin x. So integral of sin x will be cos x minus cos x plus c. Integral of cos x will be plus sin x plus c. Integral of tan x. Integral of tan x is log mod secant x plus c. All right, or minus log mod cos x. Now this is not a direct result from derivatives, but we can see if we differentiate log mod secant x, this is 1 by secant x and derivative is secant x into tan x. All right, derivative of secant x is secant x into tan x. So derivative of log mod secant x is tan x. Similarly, okay, yeah. Similarly, integral of cot x is either log sin x plus c or minus log cosecant x plus c. There are other ways to do it, to find this integral, but best is to memorize this one. We will save a lot of time. Now, integral of secant x dx is log mod secant x plus tan x. If we differentiate this, we will get the left hand side. And this we can write it as 1 by cos x plus sine by cos x. And, or convert this to this form, then we can convert it to, when we simplify, we will get this. So either it is log modulus of secant x plus tan x, and by trigonometric simplifications, you will get log mod of tan of x by pi by 4 plus x by 2 plus c. Okay, this is a simple simplification. You can try this. And cosecant x is log mod cosecant x minus cot x plus c. And a simplification of this will give you log mod of tan x by 2 plus c. Then integral of secant square x is tan x, because derivative of tan x is secant square x. And integral of cosecant square x is minus cot x plus c, of course. Integral of secant x tan x is secant x plus c. Integral of cosecant x cot x is minus cosecant x plus c. Integral of sine hyperbolic x is cos hyperbolic x, and vice versa. Integral of cos hyperbolic x is sine hyperbolic x. So for those of you who not know what is hyperbolic function, it is e power x. Sine hyperbolic x is e power x minus e power minus x upon 2. And cos hyperbolic x is e power x plus e power minus x upon 2. And tan hyperbolic x is sine upon cos, and cosecant, cot, all those things are similar to trigonometric ratios. And we get secant hyperbolic square x, integral is tan hyperbolic x. Cosecant hyperbolic square x is minus cot hyperbolic x. And secant x, secant hx, tan hx is minus secant hx. And integral of cosecant hyperbolic x, cot hyperbolic x is this. Of course, conveniently, I would say, for unless extreme case they may ask integral of hyperbolic function, even if they ask, we can simplify like this and convert. In an extreme case, if they ask, we should remember the integral formulas. It's just another few 8. We can memorize them, not an issue. These are important. After this, integral of these functions. Integral of dx upon 1 plus x square. This is tan inverse x plus c or minus cot inverse x plus c, because tan inverse x is pi by 2 minus cot inverse x. So that's why that minus, and then pi by 2 mixes with the constant. Then, okay. There is one more. Okay. I'll integral of dx upon x minus root of x square minus 1. This will be secant inverse x plus c if x is positive, or this will be cosecant inverse x plus c if x is negative. Uh, uh, x is greater than 1, I'm sorry, and x is less than -1, because cos, the secant and cosecant function lie outside of -1 and 1. So accordingly, their inverses will also follow this. Secant inverse is like the derivative is always positive, and cosecant inverse, the derivative is always negative. You can check the graphs, go back to your basic books and check. So that is why this is important. This seldom we will find a problem directly on integrals being asked like this. However, sometimes we may bump into problems, expressions like this in finding areas under curves or volumes of volumes of bound surfaces when we are using integrals. So sometimes we come across this. And finally, integral log x is x log x minus x plus c. This, of course, we will find by another method, that is integration by parts. Still, it is better to remember integral of log x is x log x minus x plus c. So these 27 are a must to remember. And the first method of integration is breaking down the integrand into, some one of these known forms. So let me take some examples, and just for practice, so examples. First one, evaluate integral of under root x plus 1 times x minus under root x plus 1 dx. How do we do it? Please discuss. I don't want to, I want to cover a lot of problems. So if I give you a lot of time to solve, it will be difficult. I want you all to interact with me. So anybody can tell what will be the next step? How will we find this integral? How will we do? Anyone
So
can
multiply and then find integral of single parts.
Yes. We have to use x power n. And when we multiply this, we see, let's multiply this under root x. So x under root x minus under root x times under root x becomes x plus under root x. So under root x multiplied by this factor. Next, 1 multiplied by this factor, x minus under root x plus 1. We can simplify this further. What happens? Plus under root x and minus under root x are cancelled. Then plus minus x and plus x are also cancelled. So we are left with integral x to the power 3 by 2. 1 plus half is 3 by 2 plus 1 dx. So just like differentiation of sum of two functions is sum of the derivatives, so integral will also be split into 2. So we get x to the power 3 by 2 plus 1 by 3 by 2 plus 1 plus x plus c. Okay, because I don't want to write C1 here, C2 here. I'm together writing one integration constant. So we get 2 upon 5 times x to the power 5 by 2 plus x plus c. This is the antiderivative. So apparently complex looking product, but what we need to do is just apply ourselves to think in terms of the results. We'll get the solution. If we just think in terms of the results, we'll get the solution. Next, so I'm just making you practice the basics. Integral, evaluate this integral. Cube root of x square minus 4th root of x upon under root x dx. Please tell me the steps.
Same as before, we'll just simplify the numerator into two parts and then take x to the power and then use the formula.
Okay. So we have x to the power 2 by 3 minus x to the power 1 by 4 by x to the power half, divide by x to the power 1 by 2. So we get x to the power 2 by 3 minus 1 by 2 minus x to the power 1 by 4 minus 1 by 2. So this is x to the power 4 minus 1. No, 4 minus 3. That is 1 upon 6. So this is 1 upon 6 minus, this is x to the power minus 1 upon 4. Okay. So be careful with the signs. So this is x to the power 1 upon 6 plus 1 by 1 upon 6 plus 1 minus x to the power 1 minus 1 upon 4 plus 1. So x to the power n plus 1 upon n plus 1. So 6 upon 7 into x to the power 7 upon 6 minus this is 4 upon 3 into x to the power 3 upon 4 plus c. So important thing to note is in derivatives there is a standard procedure. In integrals you have to do a back calculation. It is a reverse problem. So there has to be some intuitiveness in getting to the solution. Always it may not be straightforward. The solutions may not be straightforward. You just have to be thoughtful. Okay, clear? I hope you are taking along with me. Be along with me. Third question. Integral of 3 to the power 3 into 2 raised to the power x minus 2 into 3 raised to the power x upon 2 raised to the power x dx. Yes, anybody?
So when we split it in the first part, 2x will cancel, then it'll just become integral of 3. And in the second part, we can take 3 by 2 whole to the power x, and
Yes.
then we'll use the formula.
Okay. Then others should also participate. Only one student is participating. Others should also participate. Is 3 divided by 2 raised to the power x, 2 into 3 upon 2 raised to the power x. First is a constant. Integral of a constant is x, 3 times x, minus integral of a power x is a power x upon log a. Where's the result? A power x integral dx is a power x upon log a plus c. So coefficient remains as it is. Coefficient remains as it is. This is, a power x, 3 by 2 whole power x. That is the function. So we get this plus c. So this will be 3x minus 2 into 3 upon 2 whole power x